All right, homework 9.1. Let's make sure we write our name on it. And the period as well. 9.1 was all about constant rates of change. Now remember, there's a connection between a constant rate of change and what the graph looks like. If it has a constant rate of change, it's going to be a linear function. Notice that the word line is right in there. A constant rate of change is going to produce a line, a straight line, either up and away or down and towards. Let's see what they have for us today. Kumar and Janae are surveying people in their neighborhood on political opinions for the government class. They want to know how long it takes to do the surveys. So they ask us to graph the data of the survey times. Be sure to label our axis. I don't see any negatives in my X, and I don't see any negatives in my Y. So I know I only need the first quadrant. I just labeled the left-hand side X, and this is my X-axis. So I'm going to go ahead and put number of surveys. Y gives me the minutes, or the time that it took. So let's take care of our x-axis first. We've got to get from 0 to 11. So I think if we go by ones, we'll be okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. All right. Total time, we've got to get from 0 to 27.5, and I see a lot of 0.5s in there. So if we go by... Let's see if we can go by 2.5. I think that'll make it easy. 2.5 and then 5.0. 7.5 plus 2.5 is 10. Then we've got 12.5 and then 15. 17.5 and 20. 22.5, 25, 27.50. Oh, it worked out perfect. All right, so we've got 0, 0, which is called the what? The origin. All right, so we've got 0, 0. 3, 7.5. So 3 and 7.5 match up right there. 4 and 10 match up right there. 7 and 17.5. 7 and 17.5 right there. 8 and 20. 10 and 25. 10 and 25 right there. Now we need to ask ourselves, I almost connected these, but should I connect these? Can I have a half a survey? No, you don't want to collect a half a survey, and so I'm not going to leave these, I'm not going to connect these, which means I'm going to leave them just dots. Is this called discrete or continuous? It is discrete because it's only dots. It means I can't have a half. Now let's pretend like there is a line, just a light one, just so we can see it for a second. This goes through the origin. Is that called proportional or non-proportional? It is proportional because it goes right through that origin, which means that if I was to write a equation for this line, it would have just y equals some number x. It wouldn't have that plus 5 or plus 3 at the end. Proportional goes through the origin and just has that multiplying by x. All right, so we already know it's constant rate of change. So let's go ahead and take a look at the rate of change. 0 to 7.5, I had to add 7.5. 0 to 3, I had to add 3. The rate of change is the change in y, which is 7.5 minutes, over the change in x, which is positive 3 surveys. So in your calculator, if we do 7 divided by, 7.5 divided by 3, that means we're collecting 2.5. And it's top by bottom, so minutes per survey. So let me re-say what I just did. It takes 2.5 minutes to collect one survey. 2.5 minutes to collect one survey. Is the rate positive or negative? Well, it's positive. Why? Because we're adding more surveys as time goes on. So because we're not taking away surveys, so it's not negative, we're adding surveys or completing surveys. Because we are completing surveys as time passes. Sharpen my pen. All right, next question. We're back to the Ms.O Community Center. So we're back dealing with the pool. Hold that thought. This is Miss Oxley. Hi. Oh, yeah. Yep. You got it. Okay. Okay, sorry guys. The Ms.O Community Center drains and fills the pool periodically. Which set of points, the points marked with diamonds or the points marked with circles, represents draining the pool? Well, first of all, let's connect the diamonds. And let's connect the circles. So this one obviously has a positive rate of change. This one obviously has a negative rate of change. I think this will be a little bit easier now. So which set of points represents draining the pool? Well, if this is the volume, when we drain a pool, the volume gets lower as time passes. So this line right here with the dots, the volume goes down as time passes. So it's got to be the one with the dots. What is the rate at which the pool drains? Now remember, we have to make a quick table. X is your hours, Y is your gallons, and we just are going to pick 2 points and make a table out of them so we can find the rate. Let's do 0, 1200, and at 2 hours, there were 900 gallons. The difference in Y is a negative 300. The difference in X is a positive 2. So negative 300 gallons divided by positive 2 hours gives you negative 150 gallons per hour. I think that's the same as we got in class. Okay, which set of points represents filling the pool? Well, the one that's filling, the volume is going up. So the one that as time passes, volume goes up is the one with the squares. Now we need to find the rate for this one. So easy enough. Let's make another quick table. We've got hours and gallons for Y. Let's do 0, 0 for our first point. And then at 3 hours, there were 450 gallons in our pool. So from 0 to 450, I added 450 gallons. From 0 to 3 hours passed. So take 450 gallons, divide by 3 hours, and you should get positive 150 gallons per hour. So quick bonus question before we go to the next page. How long, when we were draining the pool, how many hours did it take for the pool to be empty? Well, here's the draining. Here's it at 0, so it took us 8 hours. Think about that. I think you'll have a question like that on your test. All right, we'll make a second video.